In this chapter, we're going to introduce you to the concepts of data types and variables. We're going to start this lesson talking about data types, primarily why we need them, what they do, and what they are. First of all, a data type defines the proper use of an identifier or an expression. An identifier is something like a variable or another keyword or command. An expression is like an arithmetic expression, 2 plus 2, or in the example we saw earlier with the Hello World program, the string Hello World is also an expression. So a data type determines how an identifier or an expression can be used. Data types also determine what type of data can be stored in an identifier or written in an expression. I'm going to show you some examples of that in just a moment. And then finally, data types determine which types of operations can be performed on an identifier or expression. For example, we can't add a date to a number, and we can't perform addition on a string and a date. Those are examples of operations that are not allowed because of the mixing of data types. So an example of an expression that is allowed is the expression 12 plus 2. This expression is allowed because we're taking two numeric data types, 12 and 2, and adding them together, which is allowed. On the other hand, 12 plus Mike is not allowed because it doesn't make sense to add 12 to a string. Now there is something called concatenation where you glue two strings together. What we're talking about in this expression is trying to add a number to a string, and that's not allowed. Here's an example of concatenation that is allowed. Hello plus world will give you the string hello world. Here the addition sign is being used as a concatenation operator, and concatenation is allowed between two strings. In fact, that's part of what it really is. Another example of an expression that would be allowed if the data types are correct is salary times tax rate. Here we have two identifiers, salary and tax rate, which are being used as variables. And as long as salary and tax rate have both been declared as variables that store numbers, then this expression is allowed. Next, we're going to talk about the types of data types that you find in C#. First, you have numeric data types that store numbers such as 1000 and 3.14159. You have string or strings such as hello world or the name Mike. Characters, which are individual letters or numbers, which could also be characters or even symbols. You'll notice that the difference between a character and a string is a character is surrounded in single quotes and a string is surrounded in double quotes. Another example of a data type are Booleans, or the Boolean data type, and that allows true or false values. So data types are very important to programming languages. And in the next lesson, we're going to talk about the first of those categories of data types, the numeric data type. The numeric data types handle all the numbers that will come into your C# program. The first of these numeric types are what are called the integral types. And the two main integral types that we'll work with are int and long. Int stands for integer, and long just stands for a long integer. Integer or int stores numbers in the range of -2 billion to +2 billion, leaving off some of the fractional parts there. A long stores a number in the range that you're looking at right there. I don't even know what number that is. But suffice it to say that for the purposes of this course at least, int will handle all of our integral data needs. There'll be no reason to use long in any of our programs. After int and long, then we have the floating point types, float and double. The float has a range or will hold a number 127 digits after the decimal point. That's a very precise number. Double, on the other hand, will store 1023 digits after decimal. So clearly float will handle all of our floating point needs, but for traditional reasons, we'll use double as the main floating point data type, not float. Another integral type is the byte. The byte stores a small number in the range of -128 to 127. We'll very rarely use this data type, if ever. There's also the short, which stores a number in the range of -32,768 to +32,767, and again, we'll almost never, if ever, use short in this course. And then finally, we have the char data type. The char stores alphabetical characters, as I talked about in the previous lesson, but they are stored as a numeric value, what's called the ASCII value of that character. Every symbol on the keyboard has an ASCII numeric representation, and internally that's how your programs store those characters or symbols or letters or numbers with an ASCII value. And the char actually stores the character as its ASCII value. So just keep that in mind when you're working with the char data type, and we will see some examples of char in this course. That wraps up our discussion of the numeric data types. In the next lesson, we're going to discuss some other data types. In this lesson, we're going to be looking at 3 other data types: the string, the Boolean, and the char. A string is 0 or more characters surrounded by double quotes. So for example, the phrase "Hello world," when surrounded in double quotes, becomes a string. The string data type is a class, and what that means is that there's a large collection of methods or functions that we can use to manipulate strings. Things like reverse for reversing a string, length to return the number of characters in a string, and other types of functions that help us work with strings. We'll be seeing those quite a bit as we go through the course. The string length is limited primarily by your available memory. However, in a real working program, it's not practical to have a very long string, such as several hundred characters long. If you have strings that long, you probably need to store them as text files. When we talk about strings, we're really talking about things like names and addresses and data that's of a regular standard length. Strings can be combined with the plus sign or the plus operator in an operation called concatenation, so that 2 or more strings can be essentially glued together to form one string. For example, if we had a string hello and a second string world, and we put those together with the plus sign, hello plus world, we would get one string that was hello world. So concatenation is a very common operation performed with strings. Finally, the empty string, or 2 double quotes side by side without any spaces, is a legal string object and is used a lot of times to initialize a string variable. And we'll be talking about that later in the course. The Boolean data type is used to store true-false values. And in fact, the only values that a Boolean variable could have are true or false. Booleans are used in situations where we want to make a comparison. For example, salary greater than 100,000 will return either a true or false value depending on what's stored or what value is stored in salary. They're also used a lot in repetition, where we might have a loop while the balance is less than 10,000, then perform a set of statements over and over again. And again, the expression balance less than 10,000 will return either a true or false value depending on what piece of data is stored in balance. The char data type is any character in the keyboard surrounded by single quotes. So for example, we might have the lowercase a or uppercase A or a 1 surrounded in single quotes. Those are considered char data. Notice the difference between a char, which is a single quote, and a string, which uses double quotes. Char data are stored as ASCII values. If you're not familiar with ASCII, each character on the keyboard has an integer value that represents it internally. For example, the letter A has a value, the backspace key, the enter key, the space bar, all have integer values that are called the ASCII value for that character, and it's stored internally with an integer. If you're not familiar with ASCII, you might want to search for it on the internet, and you can see a table that describes what the different ASCII values are. That wraps up our discussion of string, Boolean, and char, and now we're ready to move to the next lesson, where we're going to discuss the rules for creating and using variables, which are used to store data. In this lesson, we're going to define what a variable is and how to create variable names. A variable is defined as a name for a memory location. Rather than reference a hexadecimal value where a piece of data is stored, we use a name that has some sort of meaning for the data that's stored there. We'll talk more about that in a moment. A variable always has a type associated with it. In other words, we're storing a piece of data in a variable, and that piece of data has a type. So the variable also has to have that type. And what that means is that when we create a variable of a certain type, we can only store data of that type in the variable. So in other words, if I create a string variable, then I can only store string data in that variable. Whereas if I create an int variable or integer variable, then I can only store an integer value in that variable. When I talk about data stored in a variable, I always call it the variable's value. And that's not a technical term, it's just a term I use. I just wanted you to see that so that when you hear me say that variable's value, I'm talking about the data that's stored in the variable. As for the naming rules, the first and most important rule is that a variable name must start with a letter. It cannot start with a number or any other character or symbol on the keyboard. It has to be a letter. After the initial letter, though, the variable name can contain other letters, numbers, and the underscore character. But notice I don't include symbols because symbols are not allowed in variable names. So you can't use the $ or the % or any other symbol like that. Some examples of some legal variable names include salary, name3, where the number is at the end, and first underscore name and last name. Some examples of bad variable names include 3name, where the number is at the first of the variable, and first space name, where there's a space between first and name. The compiler would get confused by that and think that first is the variable and wouldn't know what to do with another variable name or another identifier coming right after it, because that's not part of the rules of the language. So you cannot use spaces, and you cannot begin a variable name with anything other than a letter. There's no real limit to the length of a variable name, but a variable name that's too short isn't very meaningful. For example, if I use A to store my name, that doesn't mean very much. How would I know that A has a name stored in it? Whereas if my variable was called name, then I know that a name is going to be there. And then variable names that are too long aren't practical in that you'll have to type the variable name several times in a program, and if it's more than 10, 15, 20 characters, you're going to get tired of typing it all the time. So you want a reasonably sized variable that has some meaning associated with the data that's stored there. And then finally, you should always start your variable names with a lowercase letter, because capitalizing the first letter is reserved for class names. And we'll get to that quite a bit later in the course, but for now, just understand that your variables should always begin with a lowercase letter. That's all the rules that we need to talk about for naming variables, so let's move on to the next lesson where we talk about how to declare a variable in a program. In this lesson, we're going to learn how to declare variables. Before we can use a variable in a program, we have to declare it. A variable declaration includes the data type and the variable name. There are some optional things we can do, but we're going to stick just to the basic data type, variable name for a declaration. To create a declaration, which will often be in main, although it doesn't have to be, you provide the data type along with the variable name, followed by a semicolon. Remember that a semicolon represents the end of a statement. You'll notice that the compiler puts a green squiggly line under my variable name. I'll explain why it's doing that in just a moment. For now, don't worry about it. So there's an example of an int variable. Let's do a string variable. You see there's not really much difference between the two. Let's do a Boolean variable, and let's do a char variable. And that's all you really need to know about variable declarations, except for one thing. We can put multiple variables on the same line. So for example, I can create a list of variables. We'll call this rate and ratio. And I can have as many as I want. So I could have string, last name, first name, middle name, and have as many variables as I need as long as they're of the same data type. And that's really all there is to declaring a variable. It's quite simple. You simply provide the data type first, followed by the variable name. Now let me talk about the green squiggly line. Let me put my cursor here so you can see it. The variable salary is declared but never used. Strictly speaking, that's not an error but a warning, saying that you've declared this variable but you've never used it. Once we assign data to the variable, then the green squiggly line will go away. We won't do that in this lesson, so we're going to have to end the lesson with the green squiggly line being there. But trust me, we can make it go away, and we will. There is a way, which I'll show you in the next lesson, to declare a variable and assign it some data in the same line, so that you never get the green squiggly line to start with. And like I said, we're going to talk about that in the next lesson, where we talk about assigning data to variables. So that's coming up next. In this lesson, we're going to see how to assign data to variables. And there's two ways to do it. First of all, before we start, let me introduce you to a new concept, the concept of the comment. A comment is a piece of text that is not intended for the compiler to compile, but for the person reading the program to read. So when I put comments in a program, it's primarily so that someone who's reading my program will gain something from reading the comment. A comment begins with 2 forward slashes, and then that's followed by the comment itself. So a comment can go on a line on its own or at the end of a line, so that when the compiler gets to the point where it sees the 2 double slashes, then it will just ignore the rest of what it sees. So now moving on to assigning data to variables. One way to do it is using something called the assignment statement. That's what my comment indicates there. The way you do that is you first create a variable or declare a variable. And then once you've declared the variable, then you assign it a value. To do that, we use the equal sign as the assignment operator. So this statement reads salary equals 20,000, but what it really says is assign the value 20,000 to the variable salary. So you'd read it, salary is assigned the value 20,000. In an assignment statement, we usually talk about the left-hand side and the right-hand side of the operator. On the left-hand side, there's always a variable, because that's the only thing we can assign data to. On the right-hand side can either be a piece of literal data, like a number, or an expression, such as 20,000 plus 2,000. What happens is when the compiler reads this line, it evaluates the expression to get 22,000 and then assigns that value to salary. So the assignment statement allows us to put data into a variable. Another way to assign data to a variable is to declare it and assign it data in the same line. This is also known as an initialization statement, because assigning the value 1.02 is initializing the variable with a piece of data or with a value. So these are the 2 ways to assign data, either via an assignment statement or via an initialization statement. Let me do a couple more initialization statements just so you can get the feel for how they work. We'll do one more. You should use initialization statements when you know in advance or at the time you're declaring the variable what the value is going to be. Sometimes you don't know, so all you can do is declare the variable. But if you do know at the time you're declaring the variable, you might as well go ahead and assign it the data and save yourself an extra line of code. Remember that with all these statements, you have to have a semicolon at the end of the line. And if you don't, you'll have an error in your code. So to review, we assign data to a variable using an assignment statement or an initialization statement. Assignment statements are used when the variable has already been declared and you want to put some data into it. The initialization statement is used when you want to assign the variable some data at the time that you're declaring the variable. So those are the 2 primary ways to put data into variables: assignment statement and initialization statement. And with the end of this lesson brings the end of the chapter, and now we're ready to move on to an exercise where we're going to work with the Hello World program and change its contents using variables. In this exercise, to finish up chapter 4, we're going to play around with the Hello World program a little bit. So let's start a new project. We'll name it Chapter 4, Part 7. Click OK. So just to refresh your memory, the Hello World program simply wrote out Hello World to the console. And then we have a console read key. So what we want to do here is we want to modify the program so that we can change who we say hello to or what greeting we use. So to do that, we need variables. In this case, we need at least 2 string variables. So we'll call one of them greeting and we'll call the other one who. So then once we have that, then we can say greeting equals hello, who equals world. And now our console write line statement will now become greeting plus who plus an exclamation point if we want it. So now if we run the program, we get the same result, but now we've done it with variables. And what that means is that it's very easy to change either one of them. So we can change the who and make it say hello friend. And we can change the greeting to hey instead of hello, for example. And by doing that, we increase the flexibility of our program tremendously. By using variables and being able to assign data to the variables, we set up our program so that we can modify it to include whoever we want to include in the who part and say whatever it is we want to say to them in the greeting part. Once we learn how to get input from the user via the keyboard, which we're going to learn in a future chapter, then we can completely generalize the program so that the user can enter whatever they want to enter at the time the program runs, rather than having to set the data with assignment statements before the program runs like we're doing here. So there wasn't really very much to this exercise. I just wanted to introduce you to the idea of variables and why they are so flexible and why they're so important to programming, because they really give us a flexibility that we don't have when we hard code. That's the term that we use, the console write line hello world. That's all it can say. By changing it to greeting plus who plus the exclamation point doesn't really matter there. Then we can put whatever we want to in the greeting and whatever we want in the variable who, and it just makes our program that much more useful. So that finishes up all I have to say about variables and data types for now. And we're ready to move on to the next chapter where we introduce the concepts of classes and objects.